Dr. Sridhar, back to you with another video session on control systems. So in this video session, in today's session, I am going to cover about the basic definitions of control systems. Before starting to these control systems, this control system is a combination of two different words. What is system? What is control? So control means if you want to control some of the parameters, what we are expecting from that particular system is nothing but the action to be performed, or that the action can be performed by connecting some of external devices or any controllers which will gives us controlling action. That is nothing but the control. Okay, that control is in the simplest sense. Now, if you want to perform or if you want to regulate some of the actions, some of the quantities, if you want to limit that particular quantities in a direction that what we are expecting from that particular circuit or system or process unit is nothing but the control. Okay. Just in addition to that control, system is there. What is that particular system? That system is nothing but it is a black box. Black box means empty, nothing it will be having, that takes input signal and converts to output signal. Simply, now here in this slide, I am presenting here what is a system. Now simply without having anything in your intentionally, nothing if you have in your mind, and if you are not expecting anything is going to achieve at the output terminals, simply you give the input, the system will take the input and it will transmit through it and it will send to the output. So in the simplest manner, anything if you are applying on any body, that body will react. The body will act and it will show its response, or it will allow some of the input or some of the information through it, and it will present that information at the output terminal. That is how we are saying that the body, every body will respond whenever it is excited. If you are giving something as an input and you can see some of the information at the output terminal, nothing it will be absorbed completely by the system. System will absorb in order to overcome some inertia. So some of the input it will be transmitted to the output. Okay. Now that is a simple action. Now whenever you are applying some input on us, so in another way, a collection of physical, biological, abstract components which together perform an intended objective. A system gives an output, also called response, for an input, also called excitation. Here the relation in the majority of the cases, that input is called as a excitation. So excitation means wantedly we are selecting some of the quantity, either it may be electrical quantity, non-electrical quantity, whatever it may be. Now we are choosing that quantity in order to excite the system by applying it at the input terminals. Then the system will excite and it will show its own response. That response you can see at the output terminals. So that is the thing people generally use to say that output is nothing but the more or less equivalent to the response, and input is nothing but more or less it can be called as a input. So excitation and input, response and output is nothing but analysis parameters to each other. So for any continuous time system, that input and output can be represented as input. Clearly it will be marked on the left to that system, and output is nothing but it is going to expect from the system, so it will be marked in the right side of that particular system. This is the general way of representing input, output and the system. So this is what a system is. Suppose if you are taking a classroom as a best example. Now in a classroom, what happens whenever when that classroom is said to be a classroom, or whenever a room is said to be a classroom. So what is the difference between room and classroom? Now classroom, what happens in that one, blackboard is required, some teaching medias are required, and benches are required, and for the seating arrangement for the students as well as the faculty is required, and some lighting system and fans. These are the minimum accessories. If all these are connected in a closed room with some ventilation and with some doors and all these things, then only that room is called as a classroom. Now, I want to see that classroom as a control system. Now, when the system becomes control system, now here the basic difference here, what I want to communicate you is a room. Room is nothing but it may consist of beds or kitchen, so many things. But here I mean to say that classroom. I want to design a room as a classroom. So what are the minimum things required for making a room as a classroom means benches is required. That is nothing but the seating arrangement for the students as well as the faculty, and teaching aids. Teaching aids like a blackboard and other things are required. Now, if you are arranging all these things in a proper manner, then that system is said to be or that particular room is said to be a classroom. So that is nothing but the system. System is nothing but it is a proper connection is required. So that proper connection, for what sake the proper connection is required? So definitely we are developing that particular room or we are converting that room as a classroom means something is there in our mind. So in order to achieve that particular thing, so we are converting room into a classroom. So without that intention, what is the need of converting a room into the classroom is a big question for us. So that's why, so if we are making or if we are converting a room to be a classroom means, now in that particular reaction, that converting engineer or that particular people associated with that conversion mechanism, they have something in their mind. So then only they will start their conversion process from room to a classroom. Of course, what is a classroom? Everybody knows that. Now, everybody also knows that what is the difference between a room and the classroom. So, in this simple example, with this simple example, I want to tell you that in what way system influences physical system. So, physical system means individually if you are taking any component, then that is a physical component or physical system. But main intentionally, for wantedly, if you are designing a system means, now all the physical components you have to arrange in sequential manner to achieve something whenever it is excited with some intentional inputs. So that is how the system can be defined. So here this is about the system. Now next thing is I want to make the system to be a control system. Now what is a control system? That is the second point here. A control system is an interconnection of components forming a system configurations to provide a desired system response. Here, before before talking so many technical stuff into in this starting video, let me take this simple example because everybody, I want to involve so many audience in this particular session. So that's why let me take the classroom as an example. So already we have converted a room to a classroom. Then like that, I have developed a system. Then the same system I want to design to be a control system. So what is the difference between system and a control system? That is the major thing here. We had to address that part first. Otherwise, talking so many things as a part of the control system is, I feel it is irrelevant. So first, I have converted a room to a classroom. So like that, how I have developed a system. Then the system I want to convert into a control system. There are the two stages are there. So I hope everybody understood so far what system is. Then I want to convert the system to be a control system. So what is the difference between system and control system? So only if you are verbally if you are saying that control was added to the system. So that is how that system becomes control system. So what is the control here? Control means a controlling mechanism. If it is added to the existing system, that system becomes control system. It is very clear. Nothing, there is no hidden information, hidden secret behind this. And the definition itself, it is also simple, like a controlling action. If it is provided to the system, that system becomes a control system here. So once, let me take the simple example. Let us discuss about the with that simple example what the system and what the control system. Then we will go back to the more sober technical definition for the control system. Now, let me take the classroom. All the things. So blackboard is hanged to one side of the class, and some teaching aids are properly arranged, and students have sat in their allocated places. Everything is good, but is our intention is met? Have reached to our goal? Now, what is the purpose of framing or what is the purpose of constructing a classroom have reached to that particular goal? No. Whenever some controlling action is provided or controlling action is added to the existing system, then only we can reach to our goal. The simple example is, now if faculty is not delivering his lectures in the classroom, have you reached to our purpose? Have reached your goal? No. Our goal is, the purpose of establishing a classroom is, we want to see all our students to be graduated or well settled in their labs, or they should learn the things what the teacher or faculty as delivering to the students. And they, now I'm talking about the ideal system. Now just in the ideal system, what happens, what is the need of a faculty is required, or why faculty is required in that particular class? Because classroom itself, now classroom is meant for the students, and students have to gain some practical and theoretical knowledge, who will deliver that things to the students by the faculty. Faculty will make the students so skilled and so talented. Now their talent and the skill is required for them to settle in their life. So this is a whole process. Otherwise, the students will not come to our class, and if teacher is not delivering, then that won't be a control system. So controlling action is required. Controlling action. So not only in delivering the lecture, at the same instant, some disciplinary activities also involved, because now some very effectively we have established a classroom. Now teacher is effectively delivering to the students, and some disturbance went outside that particular classroom in the veranda, something went wrong. Then majority of the students will turn their heads against to a point from where the disturbance noise came into picture. So these type of things always it will be there. Those are called as the disturbances, noises. Now we cannot design an ideal control system. Now what is the difference between a practical control system and ideal control system? In the practical control system, these type of disturbances always it will be associated with the system. So practically, in the practical systems and the ideal systems means, please try to imagine, can we develop a system more ideally? No, ideal control systems are not possible. Only what are the systems are existing nowadays on the earth. Now that all the systems are nothing but practical control systems only. So now with this simple classroom example, we can say that the sensitive difference between a system and a control system. System may not require a controlling action. Faculty, if it is not there in the system also, that is meant for something. So that is a minimum basic requirement is required for the establishment of the control system. So that is called as a system. Now, if a faculty once entered and effectively delivering his lecture, then that system becomes a controlling system. So faculty is a controller. Now he is going to direct all the students towards their goal. So that's why the faculty is said to be a controller for the total process. So like how we are going to develop a control system. So I hope with this simple classroom example, you might have understood very clearly what is system and what is the control system. So then we will proceed to the technical definition. A control system is an interconnection of various components forming a system configuration to provide a desired system response. So we are driving the students towards their goal. So that is nothing but it is a control system. What now here, some of the technical terms are also associated with this control system, the way of representing input and output, and the process mechanism. The process mechanism is nothing but it is a part of a system. So system is also called as a process, and some of the cases it is also called as a plant, process, system, all these are same. And only the thing is here in this example, we are going to add controller. Now controller, if it is added to the process, or this is also process is also called as a plant, then this total thing is nothing but it is called as a control system. So the controller will work with the target of the total formation of this system. So that is nothing but what is the desired output. So making the engineers in the engineering classroom towards their goal. So what is the goal? Settlement, completely settlement, good placements, whatever it may be. What are the ambitions of that particular students or goals of the students? With the goals as the inputs, the controller has to act. So controller is nothing but is a faculty is going to work with the ambitions of the students as the input. So desired output of the total system as the input, the controller will work. Then the controller will give some input to the process. So this is nothing but it is a classroom here. That is nothing but the plant. So required input, how much of energy, how effectively that faculty has to deliver the lecture towards the process, towards the class. Now who will decide? The controller will decide. So there is no hard and thumb rule is required. The controller is nothing but if the controller, or in this example, he may be a faculty, he has to work with the ambitions of the students. So based on the drift between the ambitions and the goal, ambitions and the effectiveness of the class, the controller or faculty has to adjust his way of teaching and how much of information the students are expecting in that particular classroom from the students. So that like that they have to change their input. So that input to the process will be the output of the faculty, output of the controller. Like this, the system will be functioned. So finally, now whether he is going to reach the output or not, he has to ensure, that faculty has to ensure. Suppose if this output is far away from this desired output, again he has to change its output according to the actual output of the system. So this output is nothing but this is the actual or practical output. This is the actual output. So here see the difference. Generally from the previous slides we have discussed that always input will be on the left side, output will be on the right side. But it is not like that here. So controller will work on the input only. But from where you are going to take the input, that is the important thing here. Controller means he has to control the total process. Now, so on what basis the controller is going to select his inputs? His or her inputs means, now what is the purpose of establishing the total system? That will be the input. So that is our ambition. That is our desired output. That's what I'm going to expect from the establishment of this whole process. So that's why this is, of course, it is an input only, but the desired output of the establishment of this whole system is nothing but input for the controller. Okay. Then the controller will regulate, or controller will generate its own inputs or her own inputs, and that input will be acted in the process. Then finally process will act according to the inputs retrieved from the controller, and they are going to give some outputs. Those outputs are called as the actual outputs. So here what are the new things we come across in this presentation? Here it is process. So what is the process? That process needs a control, because here in this example, this process is nothing but it is a classroom. So without the controller, process or the classroom will not do anything. What is the need of establishment of the process? Also meaningless. So that is the intention. That is the what my intention is. The process is nothing but it is a classroom. The process is nothing but it is a classroom. So the process definitely it has to work in association with the controller. So it means the process needs a controller. So what is to be controlled and how it is to be controlled is nothing but that's what we are going to examine as a part of these control systems. So to achieve a desired output, by regulating the inputs, we are going to reach it. So that what the process requires the regulation. Then another thing is controller. Just now also we have discussed, it is a mechanism, it is a supervisory control, it is a circuit or algorithm, whatever it may be, it has to help the system to achieve its desired output. So it provides the required amount of input to the process for a desired output. So like this, with this simple example, I would like to highlight what the system and what the control system is. I hope you understood very clearly what the system and what the control system is. See, in addition to that, a control system is an interconnection of components forming a system configuration to provide a desired system response. Like this, how we have defined the control system. This control system, a control system, because in the previous analysis, we have represented controller separately, process separately, and so many inputs and so many outputs, right? Now, if we want to simplify the way of representation of the whole system, one input, one output, and between input and output, the controller along with the process can be clubbed together into a control system. Means indirectly, this system is having subsystems or processors or plants assembled for the purpose of controlling the outputs of the processes. So again, it means the control system may be various combinations of different subsystems in it. And this control system provides an output which is nothing but response for a given input or stimulus. A control system has an interconnection of components forming a system configuration that would definitely provide a desired output in response to the input signals. So on the left side, just like our thumb rule, on the left side, we have represented inputs and desired responses because I want to see this response. So in order to reach this response, desired response, we have developed this control system, and the output of this control system is nothing but the normally actually what happens, actual response. Now here, if you could see on the left side desired response, on the right side actual response. What is this desired response and what is this actual response? Because in the beginning of this today's session, I told you very clearly that response only, but desired is different and actual is different. Desired is nothing but ideally if you are speaking, I am going to see this much from this control system. Now, if you are taking our classroom example, the faculty is same for all the students in the class, and with the same manner, he taught the lecture allotted to him in the 50 minutes class or 1 hour class, no matters. Here there is a question mark whether all the students achieve the same rank. If it is not same, all the students are able to secure their first class? No. Second class? No. Third class? No. In addition to these four relaxations, and some of them might be failed. So desired is nothing but that system we have developed. We have converted room to classroom, then classroom to control system. All these actions we have performed in order to make the students more effective, and in order to settle all the students, we have come across with these various processes. But what about our success rate? Is it 100%? No. Now there will be a deviation as per our desired output, which is nothing but the actual response of the system. So that is the thing. In order to represent the practical output and the expected output, we have clearly earmarked here that actual response is always differ with respect to the desired response. Now, various components as we discussed now, basic components of a control system, plant or process, the portion of the system to be controlled. Now, out of the total process, out of the total system, what portion is required a controller? This is nothing but the process, or this is also called as a plant. So the portion of the system to be controlled, because now in this classroom example, that classroom is to be controlled, because now in any institute, only classrooms may not be there in addition to the classrooms. Some other blocks like administration, so many things are there. But we had to regulate the classroom first. So which portion of the system requires a controller? That is nothing but the process, or it is a plant. An actuator is one more action, is a device that provides the motive power to the process. Now, what is this actuator? This actuator is nothing but it is a controller. So this is a device that provides the motive power to the process, that is the device that causes the process to provide the output. It makes the system, it makes the process to reach or to move towards its desired output. Whether this actuator 100% succeeds or how much percentage that actuator succeeds, all this depends on the effectiveness of the actuator, and not only this, it depends on the process, and not only this, in addition to these two actions, now environment also plays vital role. That is nothing but the disturbances, noise in the whole process. What are the objectives of these control systems? Now, control or regulate the output from some process to be constant at the required desired value is nothing but one of the major objective of establishing these control systems. Make the process output follow a particular changing form. These control systems, the main intention is nothing but it helps the students to be familiar with the fundamental concepts of control systems theory, and it also provides foster competence in recognizing the feasibility and applicability of the design and implementation of control systems. Now, this is a very important thing because this is one of the important subject in our curriculum also. With this, we are going to develop various control mechanisms, not only in the control systems, in allied areas also. It also helps to develop a sufficient understanding of the control system design methodology and how it impacts the system design and performance. It is a very beautiful subject. Now we can play in this control systems subject because it is control system is everywhere it will be employed because it employs linear system for specific application areas. Now somehow we have restricted our analysis to only linear systems. So what are the advantages of the control system? If we build control systems for generally there are four primary objectives, four reasons. Now we are going to build in order to meet their four primary reasons. One is the power amplification. So power amplification in order to enhance the power levels, especially in the radar antenna systems or positioning the particular system, power amplification is one of the major reason that we have built the control systems. Remote control, especially this will be used in the communication of the robots. Now in the automation systems also, these are widely used. Now, so in order to achieve this, and in addition to that, convenience of input form. That is, suppose if you want to control temperature, if you want to regulate some of the parameter, now a automation system is required. And last one is the compensation for disturbances. Now, if always the disturbances are there along the system, now it is very tough, and moreover, we are going to deviate like anything from the desired system. So that's why a control system we are going to build. Now, in addition to that, move large equipment with precision. So precision is very important parameter. So in order to achieve that, and use antennas towards the furthest reaches of universe to pick up front radio signals. Suppose now remotely if you want to work, or effectively communication channel if you want to help. So in order to achieve all these things, now we are going to build the control systems, and these are the major areas in which we are going to utilize the concepts of control system. Thank you very much for listening to these basics of control systems. Hopefully this example, this classroom example have highlighted, and this gives a sensitive difference between system and the control system. Thank you very much. Thank you for watching this video.
Like, share and subscribe. Hit the bell icon for more updates.